Greeting everyone. In this video, I'm going to explain for the first subtopic in chapter 3 electrochemistry, which is galvanic cell. Now, like in previous chapter, if you remember the word thermochemistry, it is a study of relationship between heat and chemical reaction. So the same thing goes to electrochemistry, where we are going to study the relationship between electro, which is electricity, and chemical reaction. Now, there are one thing that is related with electrochemistry, which is redox reaction. Whenever you heard the word redox reactions, so you must know that it is actually a reactions that involve reduction and also oxidation. So let's see the comparison between reduction and oxidation. Now, reduction, it is always gain electron. Okay, it's a process of gaining electron, and when it comes to the oxidation number will decrease after the production of the product. And now, the reaction of reduction, okay, it always happen at cathode. So we give the how to say abbreviation, not abbreviation, something that you can remember, which is red cat, which means reduction happens at cathode. Okay, so as you can see, this is the example here. We have copper 2 plus, copper ion, which is initially the oxidation number is 2 plus. Okay, the oxidation number is 2 plus, but after that, after the reaction, which is at the product, the oxidation number decreased to 0. Now, if we look at oxidation, it is a process of losing electron, and the oxidation number will increase, and oxidation will always happen at anode. So we make it as anode oxidation, anox. Okay, so as you can see the example here, the zinc solid initially having the oxidation number 0, but after the reaction, okay, it produced zinc ion, which is having the oxidation number 2 plus. So guys, always remember, red cat, reduction happen at cathode, and anox. Anox, oxidation happen at anode. Now, in this chapter, we are going to learn about two types of cells, that is galvanic cell, which is also known as Voltaic cell, and the second one is electrolytic cell. Now let's take a look at the comparison between these two cells. Now let's take a look at the similarity first. For both of these cells, the process of oxidation and reduction happen at the same place, which is oxidation at anode and reduction at cathode. This is fixed. Anions move to anode and cation will move to cathode. However, let's take a look at the difference between these two cells. For galvanic cells, it will convert the chemical energy to electrical energy, and this cell will generate electricity on its own. So to generate the electricity, the reaction or the redox reaction must be a spontaneous redox reaction. And for galvanic cell, anode is also known as negative terminal, as anode will produce electron, whereas cathode will known as positive terminal. This is the illustration for the galvanic cell. Now for electrolytic cells, the vice versa to galvanic cell is that it will convert electrical energy to chemical energy. This means these cells need electricity to operate. it is a non-spontaneous redox reaction, and the cathode will be the negative terminal, whereas the anode will become the positive terminal. So this is the illustration of the cell. There are 3 subtopics in this chapter. In the first subtopic, we are going to focus on galvanic cells. As you can see, we have 10 learning outcomes. In this video, I'm going to focus on the first 6 learning outcomes. So, let's learn about galvanic cell. Now, how are we going to construct galvanic cell? Galvanic cell consists of 2 cells, which we have like this, and they are separated. In each cell, they have their own electrolyte. And then we have electrode. This electrode will be connected with a wire and connected also with the voltmeter. But this cell is not complete without salt bridge. So this is the basic of galvanic cell. Let's take a look at the example. These are the 2 cells. The first one, we have zinc sulfate with the concentration 1.0 molar, and the second one we have copper sulfate with the concentration of 1.0 molar. If you have to draw, you have to write the value of the concentration like this. Do not forget the step. Now, let's draw the electrode. Do not label it as electrode, but label it as the right electrode. So this one is zinc and this one is copper solid. These are the wire and these are the voltmeter. For the voltmeter, instead of writing it as V, write it with the needle. Do not forget to label the voltmeter. And this is the salt bridge. So in this example, I'm using potassium chloride as the salt bridge. Now, how the galvanic cell operated? At anode, it will undergo oxidation. So zinc solid will be oxidized to produce zinc ion and 2 electrons. What is actually happen is the zinc atom at the solid electron will dissolve and release the electrons to form zinc ion. And what will happen as well, zinc will become negative electrode since it is the source of electron. Next, the electron will travel all through the circuit to the other cell. In cathode, reduction will happen, which is the copper ion in the copper sulfate aqueous will accept the electron and it will form copper solid. And for this reaction, you will see reddish brown solid deposited around the copper solid electrode. Copper become positive electron since it received the electrons from the other cell. Now, like what I said before, this cell will not complete without salt bridge. Now let's take a look what is salt. Salt bridge is made of a filtered paper soaked in an inert electrolyte such as potassium nitrate or potassium chloride. Or you can also use an inverted U-tube that contains a gel permeated with a solution and inert solution such as potassium chloride, sodium sulfate, and ammonium nitrate. What is the function of salt bridge? First is to separate the two electrolytes. The two electrolytes cannot be mixed together, okay? So it must be separated. Second, to maintain the electrolytical neutrality. And the most important one is to complete the circuit by allowing the ions to move between the two electrolytes. Later on in your experimentary, try not to put the salt bridge. See what will happen. Now, the diagram of the galvanic cell is not complete without the pathway of the electron. So the pathway of electron is represented by the arrow like this. Okay. And it is better if you write anode for this one and cathode for your copper sulfate. For your electrolyte, do not just write electrolyte. You have to write what is your electrolyte together with the stat and together with the value of the concentration. Okay guys, now since there are too much zinc 2 plus here, so you have to show how salt bridge work as well. Now in this salt bridge we have KCl, so Cl minus will go to this area or to this cell to neutralize the charge, whereas K plus will go here. Okay, K plus will go here. So there you go. This is the complete diagram of galvanic cell and how it works. Should you have a questions, you got a question to ask you to draw a complete galvanic cell. So here it is. Now let's write the half cell of this reaction. At anode, you are going to write the half cell like this. Okay, now these two are known as half cell. If we combine both of these half cells, we are going to get overall cells, which is this. As you can see, there are no electrons because 2 electrons had been cancelled. So whatever left will be bring down as the overall cell. Let's take a look at more example on how to write half cell. Now we have nickel and argentum. Nickel work as anode and argentum work as cathode. So we are going to write nickel as this. We know anode undergoes oxidation, and at cathode reduction will happen. So we are going to write it like this. However, for overall cell, we have to make sure that the number of electrons equal to anode and cathode. As you can see at cathode, we only have 1 electron. So what we have to do, we have to times 2 for this equation. So for overall, we are going to get this one. Again, we are not going to include the electron because the electron had been cancelled from anode to cathode half cell. Let's take a look at this example. We have cobalt for anode and copper for cathode. So at cobalt, it undergoes oxidation And at cathode, copper ion will undergo reduction. So these two will be cancelled and bring down whatever left, which is this one. So guys, this is how we are going to write half cell. And you have to know how to write half cell and also overall cell. Now, there's another thing that you have to know, which is how to write cell notation. So what is cell notation? Cell notation is a representation of a combination of reduction half cell and oxidation half cell. So this is a kind of writing. How are we going to write? Let's take a look at the next example. So say we have this overall equation or overall cell. So we can write it or we can represent it in cell notation way by writing like this. So how to understand cell notation? Okay, so for this, I'm going to give you the tips of what we call as ABC tips. So A is representing this part, which is anode. So for cell notation, you have to start with anode. Next one is this. This is bridge or your salt bridge. And next one is this. This is cathode. So A represent anode, B represent the bridge, and C represent the cathode. Okay, so that is A, B, C. Now, next one, how to write the anode? We are going to start with reactant first, then only we proceed with product. So same thing at the cathode, we are going to write the reactant first, then the product. So this one, okay, this is like a separating. This is like we are separating the reactant and the product. Okay. So for zinc, what else you need to remember? Okay, you have to write the step. Don't forget to write the step. Okay. Okay. So this is the separator, and then the product, which is the zinc 2 plus. All right. The state is aqueous, and if they give you the information about the what we call this, about the concentration, write it. So 1.0 m. And then bridge, and then copper 2 plus, again the state, which is aqueous, and 1.0 molar if given. Separate the product, which is copper solid. Okay, this one. All right, so do not forget the tips A, B, C. Reactant, product, reactant, product. So that's how we write cell notation. Now, how to write cell notations that involve gas? Okay, so let's take a look at this example. We have anode. In anode, we have hydrogen gas. So this will happen. Okay, this is what will happen in anode. And in cathode, they will produce copper solid. Okay, so as usual, can cancel this and bring down whatever left, which is this one. Okay. Now in cell notation that involve with gas, first you have to write the anode, which is the platinum. Okay, you have, sorry, not the anode, the electrode. Okay, for gas you have to write the electrode. Separate, then you start with the gas. Okay, which means this gas is produced at the platinum or at the electrode. So don't forget the stat and don't forget to put the pressure if given. Now we haven't done yet, okay, we haven't write the product, which is the aqueous. Now as you can see, at the product we have 2H+. But in cell notation, there's no need to write the stoichiometry. Just write the product. Again, do not forget to write the stat and the molar if given. Now we have write the complete anode. This is the bridge, and we continue with cathode. So we have Cu2 plus, aqueous, and 1 molar. Okay, I found out I got this wrong. This is aqueous. And then the product, which is copper solid. So remember, if it's involved gas, you have to write the electrode. Okay, you have to write the electrode. Now let's try the next example. Okay, in this example we have zinc. Okay, as you can see, the pathway of the electron is from this one, so this one should be your anode. And zinc will undergo oxidation, and this one will undergo what we call as reduction. So this one should be cathode. Okay, so anode will undergo this reaction. Okay, for cathode, you have to be very careful. We only have platinum here, so we know platinum will not involve in the reaction. But let's take a look at the electrolyte. We have here Fe3 plus and Fe2 plus. So we have 2 ions here. So you have to decide which of these 2 ions will undergo reduction. So the answer is Fe3 plus. But why? I will explain later in the next video. So ferrum 3 plus will undergo this reaction. And as you can see, we have 1 mole here for electron. So this equation have to be multiplied with 2. So we are going to get this as the overall cell. But to write the cell notation, okay, we start with zinc. Separate, we have zinc ion, bridge, then we continue with cathode. Now like I said, for cell notation, there's no need to write the stoichiometry. So we just write ferrum 3 plus aqueous, separate, ferrum 2 plus aqueous. Now if you look at the cell notation, I did not write any molarity. Why? Because it is not given. So if it's not given, fine, don't worry, just write the stat. Okay? Now let's take a look at this example. You are given cell notation, and the question is asking you to write the half cells and the overall cell. So how are we going to do this? Now, since you know that this is anode and this is cathode, this is reactant, this is product, this is reactant, and this is product, it is easy for you to write the half cell. So let's start with anode first. So for anode, we have zinc, so we write it like this. And for cathode, we have chromium. chromium ion undergoes reduction to produce chromium solid. However, as you can see, the number of moles for electron are not the same for both cells, for both half cells. So what we have to do, we have to multiply. We have 2 at anode and we have 3 at cathode. So for anode, we have to multiply with 3. For cathode, we have to multiply with 2. So that the number of electron will be equivalent to 6 for both. Then we can cancel the electron. So what will be our overall? Our overall will be this. Now that's it for this video. We will continue in the next video. Stay tuned.